In this video, we're simply going to discuss some examples from past papers and quiz papers that are relevant to help you revise trigonometry. We'll start with question 1. If sine alpha is equal to 1 over 3, where alpha is a second quadrant angle, find sine 3 alpha. The second one, part 2, find tan 2 alpha. So we'll simply make a triangle for this. They're telling us that this ratio is in the second quadrant. That's the main reason why the ratio for sine is given as what? As a positive, right? As a positive outcome. So this is what we're having. I just want to draw the x or y plane so that you see where our triangle is. This is your alpha. So sine is opposite. This is hypotenuse this side. We're looking for the adjacent. The adjacent will just be a squared. Plus 1 squared is equal to 3 squared. This will be a squared is equal to 9 minus 1. So a squared is simply 8. The root of 8, which is just the root of 8, can be 2 times 4, which is just the same as 2, root 2. So this, we can just leave it as root of 8 for convenience sake, right? We can leave it like this. I'm putting it negative because the x coordinate in the second quadrant is supposed to be negative. Or if you don't want to go about this, just remember that in the second quadrant, sine is the only thing that's positive. Tan and cosine, they're supposed to be negative. So from this same triangle, you're going to have your cos alpha is equal to adjacent over hypotenuse. Then you have your tan. Your tan alpha is simply the same as 1 over negative root 8. So these are what you get. Then we're looking for sine 3 alpha. That's what we want to get. So sine 3 alpha. So they're saying sine 3 alpha. This is the same as sine. This is 2 alpha plus alpha. Then this can be expanded using the double angle addition. For sine, this will be sine 2 alpha, then cos alpha, then plus to be sine alpha and cos 2 alpha. And this now becomes, you know what sine 2 alpha is. Sine 2 alpha is 2 sine alpha and cos alpha, right? This is what you get. There's already a cos alpha there. Then plus there's a sine alpha. You know what cos 2 alpha is? Cos 2 alpha is the same as cos squared alpha minus sine squared alpha. So we do the replacement. We're going to have 2. So sine alpha is simply 1 over 3. Cos alpha, there are the 2 of them. There's this one here, there's this one there. Cos alpha, we said, is simply root of 8 over 3. So there are the 2 of them we're squaring. Sine alpha is 1 over 3. This is simply root of 8 with a negative over 3 squared minus. This is 1 over 3, then squared. So we just simplify this expression. It will be 2 over 3 multiplying 8 over 9, then plus 1 over 3. This here will simply be 8 over 9 minus 1 over 9. This will turn out to be a 16 over 27. There will be a 16 over 27, then plus. This is 1 over 3 times 7 over 9. So this will just be 16 over 27 plus a 7 over a 27. This will just this will turn out to be 16 plus 7, that's going to be a 23, then over a 27. So we end here. This is your sine 3 alpha. That's what you get. The next one is asking for tan 2 alpha. So tan 2 alpha is simply the same as tan alpha plus alpha, which is just something that you should know by now. The double angle for tan, if the a and b are the same, this is tan alpha squared. So we're replacing with what tan is. So according to what we got, tan was 1 over root of 8 with a negative. And down here having 1 minus 1 over negative root of 8. This squared. This here is going to be negative 2 root of 8 divided by, the down part here is supposed to be 1 minus 1 over 8. this here can become, the common denominator is 8. So you have 8 minus 1. This is just 7 over 8. So we put a 7 over 8 right here. This is going to be this over root 8 multiplying 8 over 7. Then this becomes, when you solve this, it simply becomes negative 16, then 7 root 8. You can rationalize this. Negative 16, then you have 7 root 8 multiplied by root 8. This just becomes negative 16 root 8. Down there is a 7 and an 8. 8 there is 1, 8 there is 2. So the answer, the final answer that you get is root 8 over 7, which can be, this is the same as 2 root 2, right? That's 8. So this is just going to be 4 root 2 over 7. So this is the final answer that you're supposed to get. This guy here, this is your tan 2 alpha. So that answers the first question. The second one, they are saying, consider the trigonometric function f of x is equal to minus cos x plus 45. So you are having f of x is equal to 2 minus cos. This is x plus what? A 45. According to this expression, is 2 cos, there is x, then there's a plus 45. According to this, the period, you write it properly. The period is just 360 over the coefficient of x, which is a 1. So the period is simply going to be 360, or we say 2 pi. Then the first shift, we solve everything in front of cos, which is x plus 45 is equal to 0, meaning x is equal to negative 45. Then the amplitude is going to be equal to modulus of negative 1, which is just 1. Then we have a negative operation. Negative operation is present. Then we have a vertical shift. So vertical shift is a 2, and this is positive, so meaning it's 2 upwards. This number that you are seeing here, the 2, right? The amplitude was the 1 that you have here. So now if we decide to sketch this expression, this is cos, by the way. So this is supposed to be just a function that looks like this. There's a 90, there's a 180, there's a 270, then there's a 360 there. There's 1 and negative 1. Now, the first thing that we have done is just apply the period. The next thing we have to do is apply the phase shift. That's the order that we do. So phase shift means this function moves back by 45. So 0 comes at negative 45, 90 comes back at 45, 180 comes back at 135, then you have 270 comes back at, is it 235, 360 comes back at 315, so meaning everything just comes a little bit back. So our final expression is supposed to be this one in white. This is the guy that we take to be our new expression. So this is what we have when we move it back by 45. Then from here, there's a negative in front, right? So the negative is going to cause us to move this function in this manner. It's going to go like that, passing on the same points. Negative flips your function, right? This is what you get. So the white one disappears. It's just a way to get what we are looking for. Then we have the vertical shift, which is a 2, meaning all points move. So I will not draw another thing. I'll just change this. So 2 plus 1. So 2 is supposed to go at 3. Then 0 is supposed to be, this is a 2. That's a new line of access. Then negative 1 plus 2 is supposed to give us a 1. So this here is supposed to be a 1, giving us a domain of negative 45 up to 315 and a range of 1 to 3. This is basically what you have. So this is how you would have gone about sketching this question here. Hope that helps. The next question here is saying prove the identity. We want to show that the left is equal to the right, or the right is equal to the left. So the easiest thing I'll do here is to start with the right. Okay, so we're going to start with the right hand side because it has a lot of things. So we'll have 2, this is cosec x, then minus sine x, then this is 1 plus sine x. From here, we know what cosec is. Cosec is the same as 1 over sine, so that's going to be 2 over sine. Hope that's okay. Hope everyone is able to see that. This is 2 cosec, right? So this is the same as 2, 1 over sine. Remember, whenever you're multiplying, the 2 or anything that you're multiplying, this scalar only affects the thing on top. That's the reason why you are getting a 2 over sine minus, we are having a sine. Then this is 1 plus sine x, and from here the common denominator now is going to be sine x, then you have 1 plus sine x, then 2 times this, that's 2 sine x, then sine times sine, that's going to be negative sine squared. Then from here we're going to get the expression that, okay, so just a point of correction here. This is supposed to be cos, guys. I copied sine instead of cos. This is going to be supposed to be written as cos. This has to be cos even here. Yeah, this has to be cos. This has to be cos. So this, everything here has to change because this is a cos x, then this is a what? This is sine, right? So meaning this guy here has to be cos as well. Yeah, so this is what we are having now. We can do the addition. So the 2 times this is going to be 2 plus 2 cos x, then 1 times this is going to be negative sine squared, like that. So this is what we have, sine x, then we have 1 plus cos x. Then from here, we're now going to get 2 plus 2 cos x. Wherever there is sine, this side here where the sine squared, we can replace with 1 cos squared from. So hope you remember where this comes from. The rule that I've applied is sine squared plus cos squared should give us a 1, right? I just made cos squared the subject. Yeah, so I mean sine squared. When you make sine squared, you get 1 minus cos squared, right? This part. Yeah, so we're having sine x. Don't multiply the bottom part. It's okay to just leave it like this and expand it. Then the top part is just going to be 2 plus 2 cos x, then minus 1 plus your cos squared, everything over the sine x, 1 plus cos x. This is simply the same as cos squared x plus 2 cos x. 2 minus 1 is simply 1. Then down here you have your sine x and you have your 1 plus cos x. Now this is a quadratic on top. You can try to solve it. That's simply the same as cos squared x. Then you have cos x plus cos x, then plus 1. Down you're just having sine x, then 1 plus cos x. Yeah, so the guys on top can just be written as cos x plus 1 and another cos x. So there is cos x plus 1. It's nicely seen if you were to recall how you complete the square. You could have just completed the square of this. Yeah, but it's okay to have it like this, the way we've done it here. Just solve it, product sum factors and everything else. Then we cancel this part and this part. We're just going to have cos x plus 1, then everything over sine, which just happens to be equal to the left hand side. If you remember, look at the left, this guy here, right? Yeah, that's what we've simply gotten. So this is how you manipulate the first one. Then here, when they say the exact value of cos 5 pi over 3, 5 pi over 3 in degrees is going to be what? That's going to be 300. Just multiply 5 pi over 3 by 180 over pi. The pi goes 3 there, 3 there. That's a 6. You get a 300. Cos 300 is already positive because cos is positive in the fourth quadrant. So this is going to be positive cos 60. 360 minus this guy. Cos 60 is the same as what? Half. So that's what you have. Hope that's okay. That's the answer there. Then the next one, this is an equation. They're saying 2. There's a 2, then there's tan x plus 3 is equal to 2 tan what? Tan, oh, it's just 5 plus tan x. So it's a 5. Yeah, 5 plus tan x. From here, we'll get 2 tan x plus 6. When you multiply with a 2, this becomes 5 plus tan x. This will be 2 tan x minus 5 minus tan, we take the guy that has tan. So this is just tan x. It's same as 5 minus 6. So I'm taking the 6 on the other side and the 5 on the other side. The tan, So this will be tan x is equal to negative 1. X is equal to tan inverse of negative 1. This will simply give us a negative 45 because tan is an odd function. How do we get the corresponding angles of tan tan x where tan is negative, which is the second quadrant and the fourth quadrant? So it's going to be 180 plus this guy here, which will be 135. The other one will be your 360 plus this, that's going to be 315. So these are going to be the two values of x that make the equation to be equal to 0. Hope that's okay, guys. So this answers the first part of question 2. Then they gave you the range in this from 0 to 360. So the angles, are they part of this, the solution set? Yes, they are. So these are members of 0 to 2 pi. That's what you have. The next equation just requires us to sketch. So if you want to sketch this, so I'll start with this because it's very easy. Let me just prove this before we sketch. So I'll start with the left-hand side. I'm expanding this. This is sine theta plus cos theta. Equate this guy to 0. Multiply it by itself. So go through the normal steps. Don't do any shortcuts. Write the proper steps. This is sine theta plus your cos theta. Again, the same thing, multiplying itself. Then we have cos theta. This will just be sine squared theta. Sine theta and then cos theta. So this will be plus sine squared theta. And this is going to be sine squared cos theta. Then to have cos squared this. These here are going to be the two of them. So this and this is a 1. Sine squared plus cos squared is a 1. Then this is simply 2 sine theta and cos theta, which is just the same as sine 2 theta. Yeah, so we've really shown that the left can be equal to the right. So this will be the proof of that. Now look at this question here. They want us to sketch 1 plus 3 sine of x plus 90. So you can first of all pause the video and attempt it before you see how it's going to be solved. So pi over 2 is the same as 90, so I'll put it in degrees. The period is just 360 over 1 because the coefficient of x here is 1, so this is going to be a 360. The phase shift is just going to be x is equal to negative 90. You solve this, right? So this is the left shift. Then the amplitude is just modulus of 3. Yeah, modulus of 3, which is just going to be 3. The vertical shift, there is no negative here, right? So there's no negative operation. The vertical shift is just 1 upwards. So we're going up. So we are going to have, this is sine. This is one of the simplest cases you can ever have. Sine is better as compared to cos. So this is the first draft that you get, 0, 180, then 360. The amplitude, we know it's a what? It's a 3, right? You can put this if you want. Then the phase shift is negative 90. So meaning we have to move this thing backwards by 90. So the 0 comes at negative 90. The 180 comes here at 90. The 270 comes, here. So let me show it like this. Let me show these are the initial guys. Yeah, so the initial readings, let me put them in green. There was 0, there was 180, then there was 360. Now we're moving everything back. So if we're moving everything back, 0 comes here, then 180 comes here on 90, 270 comes here, then 360 comes there. That's going to be 270. So meaning your graph will just be something that looks like how we're going to have 180 is the one that comes there, right? So it's going to be something that looks like this. That's our graph. Then we have to move it 2 steps up. So meaning all the points that we're at 3 plus 2, that's simply what? 5, right? 0 plus 2 is simply 2. So this is a 0 degrees this side, but here the number is a 2. Then this plus a 2 will just give you negative 1. So technically this is your graph. We've done the movement and everything else. This is what you have. You can even give them the range, or you should be able to give them the range all the time. This is a 5. The domain is negative 90 up to 270. So I hope this is okay. So instead of me showing it on a different graph that it has moved up, I just changed the numbers here to be this. This is negative 1, 2, then 5. Yeah. So the next question. This is something that you've done over and over before. So I'll give you the formula for this. This is just sine alpha and cos alpha, right? You can make a triangle in the third quadrant. You know that only sine and cos are negative. Tan is supposed to come out as positive, right? Then here the ratio for tan is what you need, which is just going to be your what? If you make up your triangle, if this is your triangle, this is cos, which is adjacent. This is adjacent of hypotenuse. It's supposed to be a 1 here and a 4 there. Then we can use this to get this side. That's going to be 4 minus 1, or 4 squared minus 1. That's going to be 15. So this side is this part. You can get tan alpha. Tan alpha is just opposite, which is 15 over adjacent. So this is just root of 15. Yeah, you can get it to be that. Then look at the next question for sketching. So I haven't finished this other one because you know from the triangle what the other 2 guys are going to be. Then you simplify it. So this guy here, you can try it first before we do it together. I can give you here to say what your period is 180. This is 90 there. So meaning your phase shift is, when you equate this to 0, you're going to get x is equal to negative 45. Then the vertical shift is just a 1. The amplitude is this side. Which is just a 3. Yeah, and then we're able to sketch this. So this is similar to what we were from doing previously. Yeah, so yeah, I hope you're okay with this. I want to redo this again. So please just cross-check what you're going to get. You can confirm with me on WhatsApp. Then this part here, they're saying sketch the graph of the function f of x is equal to cos in a modulus. Cos just looks like that. There's a 1, negative 1. When they put modulus, it simply means if there's any piece which is down, it's supposed to come up, because modulus makes everything to be positive. So the guy in blue will just be our answer. This is what you have, and the range will change from 0 to positive infinity. The range is from 0 to 1, right? Then the domain is 1 from 0 to 360 for now, because that's the limit that they're asking us. Yeah. So this is how it's supposed to look with these dotted lines there. Hope that's okay. That's what they mean when they say modulus, meaning if they put something like this is sine, they say modulus, meaning this is going to be like this. Then if they put a negative in front, you know what you do, you flip the whole thing. Yeah, so it would have flipped like this down if it was a negative sign. Yeah, so how about this equation here? So they are saying there's 2, there's tan theta, this is tan theta plus 1, that's 0. This will be tan theta is equal to 0. And this here is going to be tan theta plus 1 is equal to 0, which is in tan theta to be equal to that. Then here, theta is equal to tan inverse of 0, which is just the same as 0 degrees. That's the only place where the tan function passes, right? So it just passes here. So just a minute. It passes here and goes like that, right? It's asymptotic here. So the answer here is 0. Then the other part has, there's a 1 here. So there's this 1 there. We take tan theta to be equal to -1. Then we're going to say tan inverse theta is equal to tan inverse of -1. So the answer here will be -45. Where tan is negative is the second quadrant. So 180 this, that's going to be 135. And in the fourth quadrant, so the two angles actually, the three of them are supposed to be these three. That's how we solve the previous question, the equation that we have. Then look at question 4. So question 4 is similar to your question 6 from your tutorial sheet. So it's the same thing that you did. You know what this is. You know what cos alpha plus beta is going to be. This will be cos alpha, then cos beta, then minus sin alpha, then sin beta. You know what this is going to be. Sin 2 beta is equal to 2 sin beta, and cos beta, I mean, this is supposed to be beta here, sorry. This needs to be beta here, beta there. So we're using these equations, but you have to create the two triangles, right? So you can try this as well. This is just simple, guys. This is create two triangles. Beta is from the third quadrant and alpha is from the second quadrant. So try this and show me how you do it if you're doubting on WhatsApp. But this is one of those free questions that you should be certain about, to say if you see this, you're able to just straight away get the correct thing. Now let's solve the next part here. The next part is a little bit interesting. Solve the equation 4 sin x cos x is equal to √3. So this is 4 sin x cos x is equal to √3. So I'll simply divide both sides by 2. I'm going to remain with 2 sin x then cos x. This is √3 over 2. And from here we know what this is. This is the same as sin 2x is equal to √3 over 2. And from here we can just say 2x is equal to sin inverse of √3 over 2. Then which angle for sine gives us √3 over 2? The only angle we can think of is 60. So 2x is equal to, there's a 60. The other place where sine is positive is in the second quadrant. So it could be 60 or 120, because 180 minus this guy, we get 120. So meaning we divide both of them by 30. This here is going to come to 40. Oh, this is 60, right? Sorry, 60 here. We are dividing by this. Okay, my bad. Yeah, so it's going to give us that. And the next question, this is on identities. We did this from your tutorial sheet, but I'll still show it here. This is just your 1. So this is 1 plus sin 2x, then plus is it sin x, and 1 plus this is cos 2x, then plus is it cos x. Yeah, this is equal to tan, so this is equal to tan x. Okay, so this is what we're having, and the substitution that we're going to do here is very straightforward. For the first part, we know this is the same as 2 sine x and cos x, then plus your sine x. This is just 1 plus. For this part, cos 2x, we know it's the same as cos squared minus sine squared, or it can be, we say 1 minus 2 sine squared x, or it can be 2 cos squared x minus 1. So this is what we're going to replace here. 2 cos squared minus 1, then plus cos squared, cos of x. So here on top, we can just factorize your sign. What remains is 2 cos x, then plus 1. The guy down, the 1 can go, they will go away. So what remains is 2 cos squared minus cos. I can simply factor out a cos here. This is going to be 2 cos x then, or this is a plus 1, right? This part cancels. This gives you sine over tan, which is the same as, sine over cos, sorry. I'm way ahead of myself here. This is sine over cos. Then this ratio is just tan x. Yeah, so this is how we basically show that. Hope that's okay. The next one, this is negative sign. So you know how the sign looks like. Negative would simply look like this. And then they're saying from the negative one, I take the expression up by 1. So if we move it up by 1, this is going to come, this is already at 1, it will come at 2. This one was here, it will be at 1. This point here will be at 0. Everything gets to move up by a single step. Yeah, so the new range will just be 0 to infinity. 0 to 2, sorry, I don't know why I keep on saying infinity. This is 0 to 2, that's your range. Yeah, that's your range. Then the domain is the one that is simply from this part here. That's the part that they want. Now they specifically want us to sketch to show up to negative 90. So we'll move negative 180. So we'll move it up to here because it can come this side, right? So this is negative pi. This is pi. So just in between here, right? That's what they want. Yeah, so the final draft will actually just be here. We can just do this. Yeah. This equation here is simply going to be done using the triangle method as well. We have sine A, which is equal to 7. 25, we can just put this to be 25 there. Then we're going to look for this expression down, which is your adjacent. A squared plus 7 squared, 25 squared. This is going to be the same as A squared is equal to 625 minus a 49, which is going to give us a 625, then we have a 49. This gives us a 6, remainder 1. This is 49 here, so it will be a 576. So the square root of 576, when you square root it, it's simply going to get a 24. So down here is a 24. Yeah, then you should have, so it was 556. Now without a calculator, how would you have gotten that the root of 556 is 576? 576 is 24. You need to break it down until you are unable to break it down. Look at the last digit here. There's a 6, meaning what small number apart from 1 can divide 6? It's a 2, right? So we use the 2 continuously. Yeah, so we break it down using the 2 over and over again. Yeah, so it will be 8, then 8. Again, use the 2, just like that. So it will be 1, 4, 4. You know already this is what? This is 12, right? 12 gives us this. 12 squared gives us, then we have a 4, which is the same as 2 by 2. There are 2 12s. There's 12 and the 12. Yeah, so 2, 2, and the 12 and the 12. So we pair them, this and the other guy. So that's where the 24 is coming from. Yeah, then we get the rest. You get your tan 2 alpha. Tan 2 theta, which is just the same as 2 tan theta. Then over what? Your 1 minus tan theta squared. The same thing that you are doing for every other question that needs you to do the triangle. Then look at the identity here that we have. So the identity here is asking us to show whether the left is equal to the right. Yeah, so this, if I may, I think this is a sec, if I'm seeing it properly. So I'll assume this is a sec. I'll start with what? With cosec. So I'll take this to be cosec A plus this is sec squared. If I'm sec A, I'll use A. So cosec is the same as 1 over sine, right? Let me use theta because I think I'm used with theta. This is going to be the same as common denominator is sine theta and cos squared theta, meaning I'll have cos squared theta plus your sine. Then here, divide everything, each particular term by cos. Divide this by cos, it will give you cos. Divide sine by cos, that will give you tan. Divide this expression here by cos, it will be sine and 1 cos. This is exactly like the left hand side. Yeah, so that's how we're supposed to do this identity here. Or you could have just started with this, then get this part. That's also easier. You could have done that. Then these equations here, the best way we can solve them. Okay, so these are the equations that they want us to solve. There's this first one and the second one. So I'll put them in a way that it's easier for you to solve. So this first one, the only thing you change is the cos squared. Put 1 minus sine squared x, then this is minus sine x. It becomes a normal quadratic that you know. This is just going to be negative sine x minus sine x is equal to 0. Factorize sine x. This is just going to be your sine x, then plus 1 is equal to 0. This is negative sine x is equal to 0. So sine x is equal to 0. X is sine inverse of 0. This will just give you 0, 180 and 360. Because of the sine function, you only get zeros at these angles, which is 180 and 360. Yeah, so this is why we're getting these three answers. Then the other one is sine x is equal to negative 1. So which angle can give us negative 1 for sine? There's a negative 1 there, right? The angle here is 270. So another angle, x value is rather 270. So this gives you a solution to the first one. For the second piece is simply going to be reduced in terms of, you know what your this is the same as cos squared minus sine squared, then plus 3. This is sine x, then minus 2. We change this part to cos. That's 1 minus, the cos, we change it to sine. This is going to give us this. Yeah, so we have something that's uniform now. You should be able to solve this because it becomes like any other quadratic that you're familiar with. This is just going to be minus 1 because 1 minus 2 is negative 1. So this is going to be a 0. Then you solve this. It's like how you solve 2k squared plus 3k minus 1. How do you solve this? Except that here sine x is the one we're letting to be k. You solve, then you substitute to get your actual answers. So I'm doing this just to guide you because it's just like a guidance. I'm assuming you're already familiar with equations. You just need to break it down to something that you will find easy to manipulate. Yeah, then the last one here, I'll be a little bit fast because I'm doing it for the battery. There's no power. So for the first expression, it's an equation as well. So we're going to let our sine x cos squared of x, then minus, we bring the sine squared on the other side. Here we're going to simply change this. We can change this to be, this is sine x, we change this to be 1 minus sine squared x minus, this is sine squared x is equal to 0. This will be sine x minus sine cubed x minus sine squared is equal to 0. Factorize sine throughout. This is sine x is equal to 0. This will be 1 minus sine squared x minus sine is equal to 0. Solve this separately. Solve this separately. You get your answers. The same applies to this question here. This is the same as, we can factorize sine. So sine can be factorized out. You get root 3. Then minus 2 cos this is equal to 0. There is sine x is equal to 0. You solve this. Root 3 minus 2 cos x is equal to 0. We can take the root 3 on the other side. It will be negative 2 cos x is equal to negative root 3. Then you are going to divide both sides here by negative 2. So you get what? Cos x is equal to root 3 over 2. What special angle gives us this? So that's going to be what? Your 30, right? So your answers are going to be found. So this is what you do. Just a guidance on 1 and 2. Then the other one, they want us to sketch, get the values of k. So the same here will be done. We'll have, they've given you this point to say when x, wherever there's x, when there's 30, the function becomes 5. So we'll put 5 where there's the f of x. This is 5 plus 2 cos, where there's x, we put a 30 and plus k. We're looking for the value of k. 5 goes this there, it becomes a 0. This is 2 cos, this is 30 and k, right? Then here we can divide by 2. We can divide by 2, meaning cos 30 plus k is equal to 0. So meaning cos inverse 30 plus k is equal to cos inverse of 0. So what gives us 30 for the cosine function? We have a 90 and a 270. So we'll do the two expressions. We're going to say 30 plus k is equal to 90, and also 30 plus k is equal to 270. So your k is equal to 240, or your k is equal to, this goes aside to be 60. They want the minimum one. So the answer we're going to go for is that k should be 60. That's what we are going to go for. Yeah, so the value of k should be a 60. Then find the expression when f of x is equal to k. So we're equating everything to k. Now that you know that there's a 5 plus a 2 cos, there is x plus a 60, equate this to 4. That's what they want us to get. Right? So we're going to get 2 cos, this is x plus 60. This is just negative 1. You do this. So cos x plus 60 is equal to negative half. Cos inverse of half. So half is just what? 60, right? Cos is positive, right? So this is going to be this. Now, the ratio here negative. Cos is even, I mean, that's what I meant to say, not positive. The value here is negative. The ratio is negative because we are looking for sections or quadrants where cos is supposed to be negative. Then we subtract this to get the real answers in those regions. So we are looking for an angle in the second quadrant and in the third quadrant. Those are the only two places where cos is what? Negative. So we're going to have 120, that's 180 minus this. The other one will be 180 plus this, that's going to be a 240. So now we are going to take x plus 60 is equal to 120. Then again x plus 60 is equal to 240. So x is equal to 60 degrees, or x is equal to this guy here subtracted by this is supposed to give us like a 180, right? This is going to give us that. Yeah, we're looking for x, by the way, not x plus 60. So that's how I would have manipulated to get this expression. Yeah, then the last one, I'll just show you how to do this last one for solving. I expect you to now be comfortable with sketching. This is just 180 here. Yeah, so I'll just do the last one where they want you to solve. There is a negative 3, then there's cos, that's 2, that's a 2x minus pi, that's simply 180, equating into 3 over 2. Divide both sides by 3, negative 3, this will be cos 2x minus 180 is equal to negative half when you divide this, right? 3 over 2 divided by negative 3. This is 3 over 2 times 1 over negative 3. Cancel this. It gives you that. So 2x minus 180 is equal to cos inverse of negative half. The ratio is negative, so we are having 2x minus 180 is equal to This gave us 60, remember previously, but the 60 we used it to get what, 120 from the second quadrant where cos is negative, and also 240 from the third quadrant where cos is also negative. So we're going to equate these to 120 and also to 240. So 120, then again we have 2x minus 180 to 240. Then this is going to be 2x is equal to, take this on the other side, that's going to give us a what? Is it a 300? Divide by 2, x should be 150. Here we are having 2x. Take the 180 this side, that's going to give us a 420. Divide by 2, this will give us x is equal to 2. That's going to be 210. Yeah, so we're having two answers. 150 and 210, the answers that are falling in this, they both qualify, so we'll pick it up. Yeah, so the only thing you need to know is, the only thing you have to do is to sketch this, show the vertical shift, the amplitude, the period, and try to sketch it. Let's see what you're going to get. Yeah, so this just I wanted this video to serve as a guide to what you are to expect. Please take some time to consider the parts that you didn't learn, like this modulus here, this part here that I was saying. Whenever there's a modulus, it simply means flip anything which is down. So if I give you sine looks like this. Sine looks like this. This is sine, right? 1 and negative 1. When I put it in a modulus expression, meaning you flip anything which is down comes up. So this is what you get. This part which was down simply flips up. Then if there's a negative, meaning the whole thing changes, it flips. Yeah, so the part which was down comes up, the part which was up comes down whenever there's a negative in front. Yeah, so this brings us to the end of the whole key trig questions. You can please send through your answers or your workings and your questions, consultations on WhatsApp. Thank you so much for watching.